Welcome to Cookies Maths and Science Hub. In this video, you'll be learning how to factorize quadratics by completing the square. Sometimes factorizations of quadratics require a few more complex calculations. One such technique is known as completing the square. To do this, we start with our standard form, ax squared plus bx plus c, and we add b over 2 squared and balance this out by subtracting b over 2 squared as well. This will give us a perfect square, which is when it factorizes down to just one term or one bracket set squared by itself. And we then simplify the other terms included. We then apply a squared subtract b squared is equal to a plus b multiplied by a minus b, if appropriate, as sometimes completing the square can lead to incomplete factorizations. So looking at the example below with just the text and our unknown variables, we'll end up with ax squared plus bx plus b over 2 squared subtract b over 2 squared plus c. Now that sounds like a lot going on, so let's look at it again with some actual numerical examples. So in our first example, we've been asked to factorize x squared plus 4x plus 1. So given that we're going to be completing the square here, we know that b is equal to 4. Therefore, b over 2 squared is going to be equal to 4, because 4 divided by 2 is 2, and 2 squared is equal to 4. Placing this into our equation, now you'll notice in both the variable example I said before and the example here, we add the 4 and subtract the 4 before the final coefficient. This is because in the next step, it'll simplify down those first 3 terms. So we have x squared plus 4x, then we add our extra values in, so plus 4, subtract 4, plus 1. We can then factorize, the perfect square there. So then we have x plus 2 squared, subtract 3, because we have collected that negative 4 and that plus 1. Our next step is we have x plus 2 squared, subtract the square root of 3. Now, the square root of 3 squared gives us 3, which means we end up with a formula that has our a squared subtract b squared. In this case, our a squared is our x plus 2 value, and our b is the square root of 3. So we can then write that out as x plus 2 plus the square root of 3 multiplied by x plus 2 subtract the square root of 3. And that is how you complete a factorization by completing the square. Now, we can apply null factor to this final step, making the whole equation equal to 0, and get that x is equal to the square root of 3 subtract 2, or x is equal to negative the square root of 3 subtract 2. You can write this out in decimal form if needed, but leaving it in surds for the most case should be fine, unless the question asks otherwise. Let's look at another example now. We have x squared subtract 8x plus 13. So once more, knowing we're completing the square, we look at our b value. So we have b is equal to negative 8. Therefore, b over 2 squared will equal 16, as negative 8 divided by 2 is negative 4. And when we square negative 4, we get 16. As a negative times a negative is a positive. Placing those back into our equation, we have x squared subtract 8x plus 16, subtract 16 to make sure we're balancing it out, plus 13. So we can see the first 3 terms form a perfect square. So we'll have x plus 4 squared, subtract 3. Then our next stage, we'll have x plus 4 squared, subtract square root of 3, which then using the simplify rule of a squared subtract b squared is equal to a plus b multiplied by a subtract b, we get x plus 4 plus the square root of 3 multiplied by x plus 4 subtract the square root of 3. Once again, at this stage, you can apply the null factor law, making your equation equal to 0, which gives us x is equal to the square root of 3 subtract 4, or x is equal to negative the square root of 3 subtract 4. Looking at a different example now, we have x squared subtract 8x take 5. So b is equal to negative 8. Therefore, once again, our b over 2 squared will equal 16. Placing that into the equation, we have x squared subtract 8x plus 16, take 16, subtract 5. Our next line, where we take the perfect square, in this case, we'll have x subtract 4, as you've got to be careful with what your b value is. As you remember, those two numbers need to add up to negative 8. So in this case, negative 4 plus negative 4. Remembering that negative 4 multiplied against negative 4 still gives us our positive 16, as two negatives make a positive. We then subtract the square root of 21. Now you'll see in this one, I skipped that extra step. Once you're a bit more comfortable with them, you can make sure you're doing it. Just make sure your layout is clear and you know which your step you're up to, as you don't want to make simple mistakes by trying to rush through a problem. Therefore, once again, we have x subtract 4 plus the square root of 21 multiplied by x subtract 4 minus the square root of 21. Applying null factor law, we get x is equal to square root of 21 plus 4, or x is equal to negative square root of 21 plus 4. Okay, our final example now, we have x squared plus 10x subtract 4. So our b value will equal 10 in this case. Therefore, b over 2 is 5, and 5 squared is 25. So our b over 2 squared is equal to 25. Placing that back into our equation, we have x squared plus 10x plus 25, subtract 25, subtract 4. Again, incorporating both lines into the next step, we have x plus 5 squared subtract the square root of 29, which gives us x plus 5 plus the square root of 29 multiplied by x plus 5 subtract the square root of 29, which leaves us with, once applying the null factor law, x is equal to square root of 29 subtract 5, or x is equal to negative 29 square root, that is, subtract 5. Thanks for watching. Hopefully now you can factorize quadratics by completing the square. Check out our other videos on quadratics and our full-length quadratic summary that goes through all the different topics of factorization and how to sketch quadratics. Hope to see you soon.